So how do we get started with deploying Sysmon with Splunk? Well, we're going to need a few things. First and foremost, Sysmon. So here on Microsoft's website, it's a simple and tiny download at 1.4 megs, and it provides both the 32-bit and 64-bit binary. I highly recommend reading through this site and looking at all the different capabilities of Sysmon. From the Splunk side, on splunkbase.com, we're going to need a few applications and add-ons here. So first, we're going to need the Sysmon app for Splunk. This one's fantastic because it gives us a lot of out-of-the-box dashboards, reports, and alerts. Next, we're going to want the add-on for Microsoft Sysmon. This will help us collect the data as well as make it CIM compliant for other SIM activities. Then we're going to want the Sysmon deploy and maintain. This one's a fantastic one because this allows any person to deploy Sysmon to any number of Windows hosts, whether you're going to do a few dozen to several hundred, several thousand endpoints. This will help you get that deployed out there. Also, it gives us the capability of updating the Sysmon configuration as well. Next, we're going to want the Splunk add-on for Microsoft Windows because, of course, we want to collect other information from our Windows endpoints, and so we're going to want to grab this as well. And to display all that data, just like the Sysmon app, the Splunk app for Windows infrastructure comes with dozens of awesome dashboards, hundreds of reports, as well as alerts. So looking at Sysmon, we need to understand what we're going to get out of this. So the Sysmon deploy and maintain app, while it's awesome to deploy Sysmon and configure it, it also comes with a base configuration. So this is a link directly to that configuration here. So Olaf has done a fantastic job of laying all this information out as well. So after you've gone through the Microsoft Sysmon website to read up on that, definitely read through this as well too. So within the deploy and maintain app, it does come with a basic configuration, and that configuration is mapped to the MITRE ATT&CK framework. So a good example here is the one that comes in is slightly older, but we have a newer one that's in here. So I've already gone ahead and downloaded the Sysmon config XML file and renamed it to config.xml. So if you're not familiar with the MITRE ATT&CK framework, I would highly recommend looking into that as well. But let's see how this configuration maps directly to some of the components in the MITRE ATT&CK framework. So as we see here, everything highlighted in green is what the Sysmon configuration that's provided will cover. So this, as we can see, is going to cover probably just about half of what we need, which is fantastic. So from instead of starting from zero, now you've got a decent way there. So once we've downloaded everything, obviously go through the documentation on Splunkbase and get everything installed on your Splunk server. So what we're also going to do is we need to deploy these specific TAs out to our universal forwarders. So in this demo, I've got one client. It's a Windows 10 workstation joined to a domain, and it's got a basic domain user that's on there as well. So what we're going to do is we're going to get these TAs configured first, and then we're going to add that to our server class in here, and then we're also going to then get that client added to that server class. So essentially we're going to marry the apps and the clients with our server class. So let's take a look and see what that looks like on the Splunk side. So we're going to need a few things here. So I've got my Splunk server installed on Linux, and I've inside here I've already copied it from our apps folder to our deployment apps folder here. So we have all three of these TAs. So the Splunk TA for Windows, I will not go through the configuration of that. It's quite lengthy, but it doesn't really map to what we're going to be doing today. But we will look at how to configure the Sysmon TA as well as the TA for Sysmon deploy. So a few things we're going to need to do. So for the TA for Microsoft Sysmon, we're going to go ahead and configure the inputs.com file. So we're going to set this to disable equals false, so that way we can go ahead and grab the data. But also I added a little extra in here. This is highly optional, but since we're using the TA for Windows, it already creates us a couple of different index files to store our Windows event logs. So I want to keep everything, since we're collecting Windows event logs for Sysmon, I'm going to put that in here by adding this index equals Win event log. Next, we're going to look at the TA for Sysmon deploy, And this one's going to give us a couple things. We'll go ahead and make sure that these are set to disabled equals false for all three. So the first one is the deploy. So the deploy batch file will take the binary that we will upload here in a moment and push that out to universal forwarder. Next, what it'll do is it'll take the config.xml file, and if you update that at any time, based on the interval, which you can change, it'll go ahead and take that config file, copy it over, and reconfigure Sysmon. And then lastly, it also creates a sysmon.log file. So this will tell us anytime that when you install Sysmon, or if it succeeded or failed for any reason. This way you can grab that data without actually having to go to every single host. So this will be really nice to have for any troubleshooting or verifying the installation or updates. So lastly, we're going to go ahead and take a look at the config.xml file. So obviously I'm not going to go through all 75,000 lines in here, but this is extraordinarily comprehensive. So in a nutshell, what this configuration file does is it allows us to include as well as exclude any processes, but also we can add conditions to it as well, so we can be extraordinarily granular. My experience with this out of the box, this is a very, very comprehensive and very intelligently designed schema for this. So definitely grab the newest updated version and get that deployed as well. So let's go ahead and take a look at that deployment. So for the TA Sysmon deploy, we're going to go into the bin folder. So within the bin folder, these are our default files that it comes with. So first we're going to update the config.xml, and then we're going to add our Sysmon binary. So we'll go ahead and update our config.xml file. So go ahead and override that, so we go from the old one to the new one. And then lastly, we're going to go ahead and copy over our Sysmon binary. So this will be the one that gets pushed out. So to help expedite this, I'm going to go ahead and reload our deployment server to go ahead and push those configurations out. And that's done. So the reason why we looked at getting the Splunk TA for Windows and the Windows Infrastructure app is also to help compare and contrast what Windows will normally log and what it can present to you. And we're going to see very quickly that it's quite lacking. Right, but we will supplement that and enhance that with what Sysmon allows us to grab. So for here, we're looking at application installs. So even over the last 30 days with our host that we have, so in our demo, the Windows 10 host, I did install a few things in here, such as obviously the Java client. But what's interesting is I installed more than just the Java client, but it's not reporting that. And you'll see why that is. So another way we can look at this is to also see what processes are running on the host. So while this is quite comprehensive, we do see we have some literal gaps in here, right? So something that's really telling is this installer. So we have an installer, but it has no start time and doesn't tell us what command ran. That's pretty bad. So while this is still very comprehensive, we can see all the information that we have in here. As for part of the demo, I used Enonite to install a few other third-party applications, like in this case, Firefox, Notepad++, and a BitTorrent client as well. So just show up in here, and you'll see that these applications are actually installed on there, but again, it's not showing up in our list. So this will help, again, Sysmon will help supplement all that information at the same time. So let's look at Sysmon. So again, for our demo, I do have a BitTorrent client running on here to generate some live traffic, some live data that we can look at, for example. So for the last 24 hours on a single host, we have over 175,000 events. Admittedly, this is orders of magnitude more than what a normal workstation would normally generate. So typically we see anywhere from 5,000 to 10,000 events per day per host, which is a tiny amount of data. So this will also help understand, like if you have a host that has an exorbitantly high amount of Sysmon events, that might be pretty suspicious. So if you're averaging, let's say, 7,000 events per host, and you have something like this that pops up, right? This will be really easy to find and easy to narrow down and start to focus in on that. So let's see what else we get from Sysmon. So now that we got our single host, pulling out 175,000 events, what does that mean? So in our network overview, we have a lot of good information. So we can see over that 24-hour period, the connections over time. We can also see the destinations. Where is this host connecting to? Right. So this might be some normal traffic, like web traffic, out to cloud services like AWS, Office 365, for web browsers. So this is normal traffic. But as you can see from the top destination ports, we also have some weird traffic as well too. So we have a lot of different odd ports that we see in here, but there's some that we would normally expect to find, like 443. Also with Splunk, we also have built-in GIP location capabilities, so we can take those external those IP addresses off the internet. We can help translate that into countries, regions, /states, and down to the city level. So for something like this, we can see that we've got traffic going to all over the world, and we need to kind of understand why that is. So really quickly, we can actually see our top applications. So we do have our BitTorrent client, but strangely enough, it's renamed to Notepad. I use this example because it was actually a real-world example I had with a prospective Splunk customer. And we were talking about some EDR solutions they're evaluating, and I had mentioned Sysmon as hey, it's free. I'll help you get it all set up, and we deployed it to a handful of workstations in the IT department. But coincidentally, there was a what my customer called, and I laughed at, a layer 8 issue. So they were suspecting that because we're bringing in firewall traffic, we had one host that was using up a large percentage of the network connections on their firewall. So we took a look at that, installed the universal forwarder on there, pushed out Sysmon, got it configured, and we found a standalone BitTorrent client that had been renamed to Notepad, just kind of fly under the radar. We all know Notepad doesn't use network connections, so it got busted pretty quickly. But it was pretty interesting to see and to also prove a point. And they would never have figured that out, in such a quick way as well. But we can also see some normal applications. So we have our Windows Defender antivirus doing its one connection, and we can imagine that's over 443 to check for definition updates. So furthermore, we can also decompose that down. So while we have our suspicious Notepad executable here, we can see that not only is it connecting out to the internet, but it's also connecting to hosts on within our own subnet. Right? So it's really interesting to see why it was doing that. So we have all the ports here. We got total count of 4,200 unique ports, which again is very suspicious, and we can help map those out down to even the protocol level as well too. Next, if we look at the process overview, this is pretty high level. We can see all the different processes that are running over a course of time. And not only that, we can find the commands that they're actually running, the actual names of the applications that are running as well, and who's actually running them. So we got our domain user here doing that, and then we also have, of course, the system accounts doing their thing as well too. What's also interesting is with Sysmon, you can actually hash those executables. And so you can configure those to use different hashing algorithms. In this case, we're using MD5. SHA-1, SHA-256 is also available as well. So if you're worried about hash collisions, you can choose some of the ones that have lesser chances of collisions. What's interesting here is we have our suspicious Notepad file as well, right? And it has its own unique hash. But also, if we look further down, we have the legitimate Notepad with its own hash. So what you can also do is you can actually have Splunk create a lookup table or KV store of all of your applications as well as all the hashes. And you can also make that like your known list as well. So the bonus is that I can create a list of known applications that have been vetted that can run with the respective hashes. So I can do a reverse lookup and say, well, if it doesn't match these hashes, let me know. All right, so you can get an alert based on that as well. So this will be a fantastic way of looking for rogue applications where someone may have renamed an application that's not supposed to be there to something that's like Firefox or Chrome.exe, things like that. Let's look at Process Watch. So the Process Watch is really good because it tells us all the commands that are being ran on the system itself. So PowerShell, while it's extremely powerful and flexible, it does have a lot of security implications as well too, and that is very well documented. So for something like this, for the demo purpose, I grabbed a PowerShell script and ran it, but there was a policy already set up. But what's interesting here is we can actually see the full PowerShell command when we ran our PowerShell script. So we can see we're getting the execution policy, and we're also seeing that the process was bypassed. So for something like this, you can set up a custom search, would be really easy, and you can just do a search for quote-unquote process bypass, or the term bypass as well. So you can collect the host name of the person that ran it, the script name, for example, and the full command. So it'd be really nice to have that as well. And then we can see our normal commands that are actually being ran as well too. So if something setting the local date and time, we can see the applications that are even querying the registry, right? So this just gives us a lot of good information. So next, let's go and take a look at file activity as well. So we need to know when applications create files at the same time. So this could be anything like cryptoware, where it's touching files and encrypting them to make new files, things like that. So this would be a great way to sniff that out as well too. So you can even set a KPI threshold. So if you see a single application do more than 50 different file creations within a short amount of time, to get that alert set up as well too. So for something like this, we can see all the files that are being created. We can also see the processes that are creating those files at the same time and in what quantity. So let's take a look at a different way to look at that type of data. So if we want to marry the processes and the files that they're creating, we can do something like this. There's a very simple one. So I took the tile target name, and we're going to do that by process. So I've kind of customized this report, so it's really easy to look at. So we can see the different processes that are running. So we see somebody downloaded a portable Sudoku app. For example, we can see it's creating its own files. We have ones for Java running, Microsoft Edge, antivirus, and here's N Night. So if we looked back at the beginning where we were looking at the processes or the installations of applications, we only saw Java. But with N-Night, it's installing things in the background differently, so Microsoft is not logging that information. Well, now if you have Sysmon, now you can see all of that information as well. Next, let's take a look at that one process notepad, right? So we found a suspicious activity, right? We want to understand what that is. So with a very simple search, I said process equals notepad.exe, and we're going to do stats count by file path and app. So what did that notepad do? So as we can see here, we've got the actual application path. So we see it's install program files under notepad. And we can also see that it downloaded Kali Linux distribution, so we can see it created the folder, it downloaded the ISO, and then the hash file. So let's enhance that a little bit further, right? So at some point, we can also go and look at the file names as well too. So in this case, we're looking at ISO files as well as AVI files, but you can free to expand this out. So if there's other file types that should be on your network, right, or you want to just keep tabs of the different files that are being created, you can just keep adding on to this condition here. So for something like this, we see that it was originally installed, right, with the BitTorrent, QBitTorrent client name. It was renamed to Notepad, but we can see that they downloaded some video files, and then subsequently the ISO files as well too. Next, let's look at the registry. So the Windows registry is full of information, and it's also hard to keep track of because there's probably millions of different entries in there. It's hard to keep track of all that. So the TA for Windows does come with 3 different options to gather data from the registry. So you can do everything, or there's 2 very specific ones, which is the run folder for the current user and the local machine. So while those are great, it's either everything or 2 specific things. With Sysmon, on the other hand, you don't have to worry about that because any application that's going to touch the registry will be collected. So you don't have to worry about enabling or customizing certain registry hives through the TA for Windows. So this would be a great way to get started with doing that as well. So this will help find malware or any misconfigurations in the registry. So if something happens in the past, you can always go back in time and do root cause analysis very quickly through Sysmon. So next, let's go ahead and take a look at our investigation tab. So the investigation one, this is pretty nice since we only have one host in here and a single user. But what's nice about this is if you had dozens or hundreds or even thousands of endpoints collecting Sysmon data in here, you would be able to go through this and sort through this very quickly. So if you have a suspicious user or there's a host that you saw that looked kind of suspicious, you can go here and you can whittle that all down. So this will be really nice to have an easy, simple way to start looking through your data. So last thing we'll look at through the Sysmon app, it does come with 25 out of the box alerts. So you can start to turn these on. I would highly advise taking these, opening them up in search to see if you actually get anything out of them, and then configure the alerts based on your incident management process. And lastly, let's look at licensing. So while in this example, I was running a BitTorrent client in the background, generating hundreds of thousands of events. And again, we're orders of magnitude over what a normal workstation would produce. But again, it does help prove a point on looking at hosts that have exorbitantly high amounts of events for Sysmon. So typically, we'll look at Sysmon anywhere from 5 to 10 megabytes a day per host. And you can also curb that down or increase it, the sensitivity, again, by looking at that config.xml file. All right, so if it's kind of too sensitive, you can start to exclude those applications if you absolutely don't need them. But definitely collect them up front and then make that determination, because now you have quantified data to back that up. So looking at here, even on our busiest day, we brought 131 megabytes of Sysmon data, and we're probably pushing close to 500,000 events that day. So again, for this one, we're looking at 30, 40 megabytes a day for that one host, again, running a BitTorrent client. So really simple to set up, deploy, get so much value out of it, supplement what you're currently getting through the TA for Windows. And if you're also looking to evaluate other EDR products out there, and they're going to have a cost to them, Sysmon's a fantastic start. Right? It's simple to use, get a lot of data out of it. But I do challenge you to take a look at other EDR products as well. Go into Splunk base. We have a lot of integrations with CrowdStrike, Carbon Black, Cylance, Sophos, Endgame, Symantec. Right. So if you already have one today, you want to supplement it with that. This would be a fantastic start as well. And also with Sysmon data already collected, this will help you get into like our advanced SIM product, enterprise security, to get even more value out of that product as well.